All right, welcome everyone. Today we're going to be diving deep into the world of your blood. You know those red blood cells constantly working hard, carrying oxygen all over your body?
Yeah.
Well, we're going to be uncovering a really important measurement related to those cells. It's called mean corpuscular volume, MCV for short.
Hmm.
You can think of MCV like a detective clue for your health.
Exactly. It tells us the average size of your red blood cells. And you know what? That can be surprisingly useful when it comes to figuring out what's going on if someone has, like, anemia.
Exactly. And we've got some excerpts from a medical text that goes into detail about MCV. We're going to break down what this number means and why you should care.
It all starts with a pretty straightforward formula. To get the MCV, you take the hematocrit, divide that by the red blood cell count, and then multiply by 10.
Okay, wait, hold on. Can you remind me again what exactly is hematocrit?
Oh, sure. So the hematocrit is just telling us what percentage of your blood is actually made up of red blood cells. So when you combine that percentage with the actual number of red blood cells you have, well, then we can start to get an idea of their average size.
So just thinking this through, like, if your hematocrit is low, meaning you have fewer red blood cells overall, your MCV could also be lower too, right? Like the cells might be smaller.
Yeah, exactly. That's why it's really important to understand both of those values, both the hematocrit and the red blood cell count, when you're looking at that MCV number.
So interesting. And you know what's fascinating to me is that based on a person's MCV, their red blood cells actually fall into different categories.
Right. So we've got microcytic, which is where the cells are smaller than normal. You have normocytic, where they're in the normal range. And then you have macrocytic, where the red blood cells are larger than normal. And each one of these categories gives us clues about what might be going on.
Okay, so let's break those down a bit more. What causes red blood cells to be microcytic or smaller than usual?
Well, a lot of times it points to a problem with hemoglobin production because hemoglobin is crucial. I mean, it's the protein in those red blood cells that actually carries oxygen throughout your body.
Yeah.
And so conditions like iron deficiency anemia or thalassemia, they disrupt that whole process. And what happens is you end up with smaller, um, less efficient red blood cells.
So if you think about it, like if you don't have enough iron, you can't build enough hemoglobin, and the red blood cells just end up smaller. It's kind of like uh, trying to build a house but not having enough bricks.
Exactly, exactly. And then thalassemia is a genetic disorder, and that also affects how much hemoglobin is produced. But unlike iron deficiency, this one is inherited, meaning it's passed down through families.
Gotcha. So with thalassemia, it's not a matter of like, getting enough iron in your diet or anything like that. It's more of a problem with the actual genes that control how your body goes about making that hemoglobin.
Yeah, precisely. And it can be, it can range in severity. It can be from mild to, quite serious. In some cases, depending on the type of thalassemia, people might even need regular blood transfusions to keep their red blood cell levels healthy.
That's pretty incredible. It really just highlights like how such a simple measurement like MCV can lead to diagnoses of conditions that are pretty complex.
Absolutely. And our source even mentions another interesting condition that can be associated with microcytic anemia, and that is what's called anemia of chronic disease.
Now, didn't we, no, wait a minute, because didn't we say earlier that anemia of chronic disease can also be associated with normocytic anemia? Like, how does that work?
That's a great question. So anemia of chronic disease can be a bit tricky because it can actually present with either microcytic or normocytic red blood cells. It really depends on the underlying condition that's causing it.
Okay, so it's not as like straightforward as the iron deficiency or the thalassemia.
Yeah, right. So in anemia of chronic disease, it's actually the chronic inflammation from things like rheumatoid arthritis or kidney disease or even cancer that can end up interfering with the body's ability to use iron properly. And that's what can lead to those smaller red blood cells.
So even if there is enough iron present, the body can't actually use it properly because of the inflammation that's happening. Wow, it really highlights how interconnected all of our body's systems are.
Yeah, that's a great point. It's like having all the right ingredients to bake a cake, but you can't mix them together properly because, your oven's broken or something.
Yeah, I like that analogy.
Hmm.
Okay, so we've talked about conditions where the red blood cells are too small, or they're normal size, but maybe there's not enough of them. Now let's move on to macrocytic anemia. This is the category where the red blood cells are actually larger than normal. What causes that to happen?
So in those cases, the cells often haven't matured properly. Things like vitamin B12 deficiency or folate deficiency can be big culprits here.
Okay, so why are those vitamins so important for red blood cell development?
Well, these vitamins are crucial for something called DNA synthesis. And DNA is basically the blueprint of our cells, right? And synthesis is the process of copying that blueprint so the cells can divide and multiply. So if you don't have enough B12 or folate, then red blood cell production gets all messed up, and you end up with these larger, immature red blood cells.
Interesting. So it's not even that the cells are just bigger; it's that they haven't developed properly.
Exactly. Exactly. It's like you're trying to bake a cake, but you don't have enough eggs. It's just not going to rise and develop the way it should.
I like these analogies. Very helpful. And it's interesting because our source material even mentions that things like um, alcoholism can affect red blood cell size and can lead to macrocytic anemia. I
Hmm.
hadn't realized that lifestyle choices could have such a direct impact on our blood like that.
Yeah. Yeah, and that's what's so fascinating about the MCV. It really does provide a window into, your overall health. Now, before we move on to more of the specific conditions within each of these categories, did you have any questions about anything so far?
Yeah, it's amazing, isn't it? Like, who knew that just one little measurement like MCV could tell us so much about what's happening inside? So now let's dig a bit deeper into each of those MCV categories, and let's see, what specific conditions they might point to.
Sounds good. Let's start with microcytic anemia, since we know it's often linked to those hemoglobin issues.
Mhm.
So, what are some of the key conditions that fall under that category?
Well, like we were talking about earlier, iron deficiency anemia is definitely a common one, and it's pretty simple. If you're not getting enough iron, like in your diet, or if your body just isn't absorbing it properly, well, it's going to struggle to make enough of that hemoglobin, and that's what leads to those smaller red blood cells. Yeah. Our source even mentions that in addition to just feeling tired all the time, which I think we've all experienced at some point, people who have iron deficiency anemia can experience things like um, pale skin, shortness of breath, even brittle nails. It's crazy how many effects can come from that one little deficiency.
Exactly. It's like a domino effect almost. And then of course there's thalassemia. We touched on that briefly. It's a genetic disorder that also affects hemoglobin production, but this time it's inherited, so it's passed down from parents to children.
Right. So with thalassemia, it's not an issue of just getting enough iron. It's more like there's a problem with the genes that actually tell the body how to make that hemoglobin.
You got it, exactly. And the severity can vary quite a bit. Some people might only have mild symptoms, while others might have more serious complications. And in fact, our source even mentions that some people with thalassemia, depending on what type they have, might even need regular blood transfusions just to maintain healthy red blood cell levels.
Wow. It's just wild to think that something as seemingly simple as MCV can be like this clue that leads to the diagnosis of such a complex condition.
Oh, absolutely. It's really quite remarkable. And you
Yeah.
know what? Our source also mentions another condition that can be associated with microcytic anemia, something called anemia of chronic disease.
Now, wait a minute. Didn't we say earlier that anemia of chronic disease can also cause normocytic anemia? So, how does that work?
Yeah, that's a great question. It can be a little confusing because it can actually show up with either microcytic or normocytic red blood cells. It really just depends on what exactly is going on underneath, what's causing it.
Oh, okay. So it's not as simple as iron deficiency or thalassemia.
Right, exactly. So with anemia of chronic disease, what's happening is you have this chronic inflammation going on in the body. This could be from things like rheumatoid arthritis or maybe kidney disease or even cancer. And that inflammation is what ends up messing with the body's ability to use the iron correctly, which can then lead to the smaller red blood cells.
So even if someone has enough iron, their body might not be able to use it right because of that inflammation. It really shows just how connected everything is, in our bodies.
Oh, I know, right? It's incredible. It's like, you've got all the ingredients for a cake, but then your oven's broken, so you can't actually bake it.
Right. Okay, so we've talked about conditions where the red blood cells are either too small or normal in size, but maybe there just aren't enough of them. So let's move on to macrocytic anemia, the one where those red blood cells are actually larger than normal.
Yep.
What causes that?
So, in those cases, a lot of times it's because the cells just haven't matured properly, and things like a vitamin B12 deficiency or a folate deficiency, those can often be the culprit.
Right. Okay. And why are those vitamins uh, so crucial for red blood cell development?
Well, they're both super important for something called DNA synthesis. And DNA is basically, it's like the blueprint for all of our cells. And synthesis is how that blueprint gets copied so the cells can divide and multiply. So if there's not enough B12 or folate, then, well, then the red blood cell production gets messed up and you end up with these larger, immature red blood cells.
Oh, okay. So it's not even just that the cells are bigger, it's that they're not developing correctly.
Exactly. It's
It
like you're trying to bake a cake, but you don't put in enough eggs. The cake just won't rise right.
makes sense.
Right.
Getting
Okay.
hungry. But you know what else is interesting? Our source mentions that things like alcoholism can actually affect red blood cell size and can lead to macrocytic anemia. I had no idea that your lifestyle choices could directly affect your blood like that.
Yeah. It's pretty fascinating, right? And that's just one of the reasons why that MCV can be so insightful. It really gives us a peek into your overall health. Now, before we move on to some more specific conditions within each category, did you have any questions about anything so far?
It's pretty amazing how much we can learn from just this one single measurement. But as we've been talking about, MCV isn't the be-all and end-all. There are other things that can affect those numbers, even if someone is perfectly healthy.
Right, exactly. There are definitely other things that can throw off the results. So let's look into those factors. Like what about aging? Does our MCV change as we get older?
Yeah, that's a good question.
It can actually. Our source mentions that those MCV values can actually fluctuate quite a bit throughout life. Like newborns tend to have higher MCVs, but then it gradually decreases as they grow up.
Oh, wow. So those little babies have extra large red blood cells. That's interesting. What about, are there differences between men and women?
That's another factor. On average, men tend to have slightly higher MCV values compared to women.
So both age and sex can play a role. Now, we've also mentioned a few times how dehydration can affect MCV. Can you explain that a little more?
Sure. So when you're dehydrated, your blood actually becomes more concentrated because there's just less water in it. And that can actually make the red blood cells seem bigger, even though they haven't actually changed size.
Oh, wow. So you're saying dehydration can actually lead to a falsely elevated MCV.
Exactly. It's not that the red blood cells themselves are bigger, it's just that the blood is more concentrated.
Hmm. Never would have guessed that. What about medications? Can they mess with those readings too?
Oh, absolutely. Some medications can interfere with DNA synthesis in the red blood cells. This can be medications like some of the antiretroviral drugs that are used to treat HIV. And so that can lead to larger cells and a higher MCV.
Wow. So even medications that aren't specifically for blood health can still have an impact. Our bodies are so complex.
I know, right? It's incredible. And our source even mentions that even lab techniques can sometimes affect those MCV results.
Really? I mean, how could the lab itself influence the results?
Well, so, different labs might use slightly different methods or different equipment to measure the MCV. And so those little variations in technique can lead to some slight differences in the results that you get.
Oh, okay. So it's not just about looking at the number itself, but you kind of have to understand how the lab actually came up with that number.
Exactly. And again, that's why it's so important to remember that the MCV, while it is a valuable clue, it's not a standalone diagnosis.
Right. You need the whole picture, right?
You got it. Things like your medical history, your symptoms, other blood test results, even your lifestyle factors, all of those things together are what helps to give us a clear picture of what your MCV really means.
So what does this all mean for our listeners out there? What's the big takeaway from all this MCV talk?
Yeah. I think the most important thing to remember is that MCV is a really useful tool. It gives us this glimpse into your blood health, but it is just one piece of the puzzle. It's really more like a starting point, a clue that can lead to further investigation.
Exactly. And that's why it's so important to discuss your results with your doctor.
Absolutely. They can help you make sense of what those numbers actually mean and figure out what the best next steps are.
This has been such a fascinating deep dive into the world of MCV. We started with just calculating this one seemingly simple measurement, and we ended up exploring all these complex conditions that it can help us diagnose.
Yeah, and we've seen that it's not just a static number. It can change depending on your age, your sex, your hydration levels, even the lab techniques being used.
We hope you've all enjoyed this deep dive and learned something new. And hopefully this episode has given you the knowledge and the confidence to really take charge of your own blood health.
Yeah, remember, knowledge is power.
I've said it better myself.
But before we go, I do have one last thought-provoking question to leave you all with. We've talked about medications and hydration, but what are some other things in your everyday life that you think might affect your MCV? Think about it. And with that, this concludes our deep dive into the world of MCV. See you next time.
You've been listening to the Learning Podcast, a production of metaNESTA. Remember, learning is a journey, one step, one insight, one skill at a time. We'll see you next time. Keep learning, stay curious, and as always, be awesome.